Hey everyone, we're going to pick up our review here and we're looking at writing a line that passes through 9, negative 7 and is perpendicular to the line whose equation is y equals 1/4 x plus 1. We got to do it in point slope form and in slope intercept form. So let's give ourselves some space. I've got the point, I've got the line, and what we need to do from this given line is extract the slope. M is equal to 1/4. And since we're looking at something perpendicular, our new m, call it m2, is going to be the reciprocal of that, 4, and then we negate that reciprocal, so negative 4. That gives us perpendicular. That's the perpendicular relationship. So we take, and it's going to be y minus y1, that's negative 7, is equal to our new slope, negative 4, times x minus x1, or 9. Make that look like a 7. So y plus 7 is equal to negative 4, x minus 9, and that's our point slope. And we can keep going and get y plus 7 is equal to negative 4x plus 36, or y is equal to negative 4x plus 29, and that's slope intercept. Great. Let's go on to our next question. We're going to use the graph to determine open intervals on which the function is increasing, decreasing, or constant. So I don't see any increasing, but I do see from here on down this is decreasing. So let's see here. So I'd say negative infinity because of this arrowhead that's telling me that it just keeps going to infinity, down to about here at negative 2. So negative infinity, negative 2. So it's not increasing, decreasing on negative infinity to negative 2. And then it's constant from negative 2 on. So it's constant from negative 2 to infinity. All right. And that takes care of that question. Let's look at number 14 here. Use the given conditions to write an equation for the line in point slope form and slope intercept form. And we're looking to just work with the line passing through the points, negative 5, negative 3, and 5, 11. And the first thing we're going to need to do is find the slope. And that'll be 11 minus a negative 3 over 5 minus a negative 5. So I get 14 over 10, which is 7 over 5. Great. And then we're going to have y, we'll say plus 3, is equal to 7 over 5 x plus 5. Great. So y plus 3 is equal to, oh, and this, by the way, this is our point slope form. And if we keep going and we get 7/5 x plus 7, or y is equal to 7/5 x plus 4, that's our slope intercept form. All right, great. On to our next page. So for number 15, we're asked to find f plus g, f minus g, fg, and f divided by g, and the domains for each one of those four for the functions f of x is equal to 3x squared plus 20x plus 12, and g of x equal to x plus 6. I've got these written out so that we've got some space, and let's start with the sum, f plus g. I'm going to take 3x squared plus 20x plus 12, and I'm going to add to it x and 6. And what we'll get here is f plus g of x, which is 3x squared plus 21x plus 18. All right, let's do the same thing with the difference. We're going to take, for the difference, 3x squared plus 20x plus 12. We're going to subtract x, and we're going to subtract 6. And we'll get 3x squared plus 19x plus 6. And that is f minus g. Now, before we get into the products, let's take a look at the domain and the range for these right here. The domain is negative infinity to infinity. There's nothing crazy going on in the domain, and it's the same thing with the range. There's no division, there's no square roots, and for our second purple equation here, for the domain, it's again negative infinity to infinity, and the range is negative infinity. Well, actually, I take that back. That's not the range. And do we need to find the range for these? Okay, just the domain. So I'm wrong on the range because these are parabolas. I thought they were cubics for a second. But these are parabolas, so the range is going to have a maximum, right? There's always some sort of like, here's my parabola, here's my maximum. And we could find that in the parabolas section, but we're not going to right now. Let's work on the product next. Let's find f times g. So fg of x is going to be 3x squared plus 20x plus 12 times x plus 6. So that's 3x cubed plus 20x squared plus 12x plus 18x squared plus 120x plus 72. 3x cubed plus 38x squared plus 132x plus 72. One last thing to do, and that's find the quotient and its domain. So that's 3x squared plus 20x plus 12 divided by x plus 6. So x cannot be equal to negative 6. The domain's going to exclude that, negative infinity to negative 6, unioned with negative 6 to infinity. Is this in simplest form? Does this factor? Well, we can't just straight factor out a 3. 3 times 12 is 36. So that's 6 times 6. Let's see here. 1 and 36 is 37. 2 and 18 is 20. So this factors out to, not just yet. 3x squared plus 18x plus 2x plus 12 over x plus 6. So that's 3x times x plus 6 plus 2 times x plus 6. 3x plus 2 times x plus 6 divided by x plus 6. So f divided by g of x turns out to be 3x plus 2 on the domain, negative infinity to negative 6, unioned with negative 6 to infinity. So on all real numbers except for negative 6, it's equal to 3x plus 2. Okay, let's keep moving and let's look at our next exercises here. I think this is all of this page, yeah. So we'll jump to I'm missing number 16. Why aren't you showing me number 16? There it is. 16 is important. 16 is the average rate of change problem. So we've got the square root function, and we're going to take the square root of 9, and we're going to subtract from it the square root of 4. So that's 3 minus 2, that's 1. And we're going to say, well, we're going from 9 to 4. So 9 minus 4, so that's 5. What's our average rate of change? 1/5. Number 17. Write in standard form the equation of the circle with the given center and radius. Okay, I think we remember how to do this. It's x minus its center, so x minus a negative 6 squared plus y minus the little vertical shift, y plus 8 squared is equal to radius squared. Alright, I think we've got it. Number 18, we're going to evaluate f of x equal to x squared minus 8x minus 4 at the given values of the independent variable and simplify. So f of negative 2 is going to be negative 2 squared plus 8 times negative 2 minus 4, which is 4 minus 16 minus 4, which is a negative 16. At x plus 9, let's give ourselves a little bit of space. X squared minus 8x plus, minus 4 at x minus 9 plus 9. So that's x plus 9 squared minus 8 times x plus 9 minus 4, x squared minus 18x plus 81 minus 8x minus 72 minus 4. Oh my goodness, that's x squared minus 26x. This gives us plus 9 minus 4 is plus 5. And then lastly, we need to do it at negative x, right? Correct, at negative x. So that's negative x squared minus 8 times negative x minus 4. X squared plus 8x minus 4. And that's going to be f of negative x. And this is f of x plus 9. Great. Next question. Okay, let's take a look at number 19 here. We're going to use the graph of f to draw the graph of its inverse function. And of note right here is the point 0, 1, which when we turn x's to y's becomes 1, 0. And then the other point that we're looking at right here is at about 2. It's 1, 2, 3, 3.5. So we also need to find 3.5, 2. That's the other point that we're looking for. So 1, 2, 3.5, 2. Right here. Look at that. That's what we're looking for. And if you take a look and you draw this y equals x line, you can see that these two lines are mirrored about it, right? It looks like if you folded it up like a piece of paper on this line, y equals x, they would lie atop each other. That's what we're looking for an inverse. Find the midpoint of the line segment with the following endpoints. Well, to find a midpoint, I'm going to take the y's, negative 8/3, add to it 1/3. We get negative 7/3, and we divide that by 2. Negative 7/6. We're going to do the same thing with the x's. Negative 8/3. We're going to add to it negative 7/3. Divide all of that by 2, so that's negative 15/3 divided by 2. Negative 15/6. So the midpoint is negative 15/6, negative 7/6. That's our midpoint. Great. Let's keep going. I think we're almost done. Determine whether the following relation describes a function. Give the domain and range for the relation. Function means one input or one output for each input. So if I'm looking at the inputs, I better not see another 2. Is there another 2? No. Is there another 5? No. Another negative 3? Nope. Just the negative 5. So we have unique x's, we'll call them. So yes, it represents a function. What's the domain? 2, 5, negative 3, negative 5. 2, 5, negative 3, negative 5. What's the range? 1, negative 5, 1. There's 1, there's negative 5 up. So it's this one right here because there's no negative 5, no 1, no 1. So 1, negative 5, 5. Oh, doesn't go to 5. 5 and 3. Is that a negative 5? Oh, that is. So 5 isn't part of the range, right? It goes to 1, it goes to negative 5, negative 3, and negative 5. So this is out because of that 5. This is out because of the 2. So it's this one right here. 1, negative 5, negative 3. 1, negative 5, negative 3. All right. Give the center and radius of the circle as described by the equation and graph the equation. Okay, so the center is at negative 4, means that's at x is 4, so x minus 4 means that the x coordinate is 4, y minus 2, so that subtraction of 2 means that the y coordinate for the center is at 2, and then 25, the radius is the square root of 25, which is 5. So here's 4, here's 2, bloop bloop, my radius is 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and we're going to go up to 7. We're going to go down to 3, great. And let's try to draw a circle here. Oops, it's that kind of circle tool. Looks pretty good. There's our circle. So what's the domain? The domain's going to go from 4 minus the radius, negative 1, to 4 plus the radius, 9. So the domain is negative 1 to 9. And what about the range? The range is going to go from 2 minus the radius, negative 3, to 2 plus the radius, 7. So the range is negative 3 to 7. All right. Let's take a look at some composition. We were given the equations f of x is equal to x plus 5 and g of x is equal to 5x plus 2. And we're asked to find f of g, g of f of g of negative 2, and g of f of negative 2. So let's start by finding f composed with g of x, which is f of g of x. So f of x is equal to x plus 5. So f of g of x is g of x plus 5. And I'm going to replace g here, g of x, with g of x. So that's going to be 5x plus 2 plus 5. So this is 5x plus 7. That's f of g of x. And f of g of negative 2 is 5 times negative 2 plus 7. So that's negative 10 plus 7. That's negative 3. Cool. Let's do g composed with f of x. That's g of f of x, which is 5 times f of x plus 2. And for f of x here, we're going to do x plus 5. So that's 5 times x plus 5 plus 2. That's 5x plus 25 plus 2. That's 5x plus 27. G of f of x. So g of f of negative 2 is 5 times negative 2 plus 27. So that's negative 10 plus 27. That's 17. Great. And that's number 23, and I think we've got just one more page of these to do. We're going to use the graph of g here to find g of negative 3. So let's see here, negative 2, negative 3, oh, right here at 9. G of negative 3 is 9. Great. 25. Use the given conditions to write an equation for the line in point-slope form and in slope-intercept form. The slope is negative 1/8 and it passes through 7, negative 9. I'm going to take y, I'm going to subtract the y coordinate from it. I'm going to set that equal to my slope times x minus the x coordinate. So this is y plus 9 is equal to negative 1/8. Let's distribute. We'll go ahead and we'll just distribute that. Negative 1/8 x plus 7/8. Okay. So this right here was our answer, would be our answer to the first part, point slope form. And then after we subtract 9 from both sides, y is equal to negative 1/8 x. 9 is 72/8. So this is 7 minus 72 over 8. So that's a negative 65/8 or 8 1/8. And that right there, that's our slope-intercept form. What about the distance formula? I think we can use the distance formula. The distance formula is the difference in y squared plus the difference in x squared, and then you take the square root of the entire thing, right? So the distance between negative 7, negative 2, and negative 2, 3. I'm going to take 3. I'm going to subtract a negative 2. And I'm going to want to square that. We'll get 5 squared, which is 25. I'm going to add to it negative 2. And then subtract that negative 7. So subtract a negative 7. So that's another 5 squared. So 25 plus 25. And remember, we need to take the square root of all of this to find the distance. So the distance is the square root of 50, or 5 square roots of 2. That's our distance. And that's actually our worksheet all solved out. So thank you, and I'll see you guys later. Good luck studying.